Today I'd like to talk about route splitting, vendor caching, and Reactrata 4. Before we jump into it, how many of us over here actually use route splitting in our production app? Any hands? Cool. How many of us use vendor caching for long-term vendor caching? No? Okay, someone else there. Oh, you're right in the front seat. That's good. And Reactrata 4, how many of us have converted our code from Reactrata 3 to Reactrata 4? Cool, cool. Last time I did this talk, everyone knew everything, so I was like, Jesus Christ, there's no point being here. Cool, it's good, it's good. Something I can impart. But yes, one more thing about me, I kind of use Twitter and LinkedIn as well. If you ever like a Motivation Monday post, you hate your job, I hope you don't. You can like my things if you want. Sure. Subtle thing. Cool. So how does it work? The tradition is we have a backend, maybe Node, because I'm a JavaScript person. Node loads some HTML with some JavaScript bundle file that comes through Webpack. We all love Webpack. And then the Webpack basically has all our routes, and then we can go ahead and load that application. Now, you can even go ahead and do server-side rendering, which helps with SEO. Sometimes, I mean, it doesn't matter. Some people say SEO doesn't work, but if you use, thank you. If you use Yahoo or Bing, I would suggest you check up with your local doctor. But I mean, you use Google most of the time, so it's good, right? So this server-side rendering isn't that big of an issue. So you end up getting the whole code sometimes. Sometimes you have an application that is maybe 15 or 20 routes or 20 pages long, and all of that comes to you, and you really don't care. You don't want your customers to see all 20 pages when maybe some of them might just want 3 or 4, right? So that causes an issue, and sometimes the case is that, wait, the whole point of front-end or single-page front-end applications is everything's loaded, everything's clickable, you click it, and everything's there. But then again, there opens up the whole concept of really big applications like Facebook, or you have, well, Instagram's a single page, but still, let's assume it's a really big application. And you're moving through the app, and sometimes you don't want to load everything at the whole time. This is a traditional system, or a traditional, I guess, config we have, where we have our basic route. This is me using Reactrata by the React training guys. And we have an index route. We have routes that have a path that matches to a particular URL. And we have a location component or product component. We have the colon name for those who are new to it. That basically allows us to go ahead and dynamically load in a route or match a route dynamically. If maybe you're using Facebook and you have a very specific URL to your user ID. So, getting back, what's happening when we compile our code with Webpack? Right. So Ryan Florence, one of the guys who's part of the React team, went ahead and said, we used to use require.ensure. That allows Webpack to go ahead and realize that we're dynamically loading some code. So what basically happens is when Webpack is right about to compile our code, right when it says, all right, I'm going to go through this entire dependency graph of 50,000 things, it starts parsing through and keeps track of wherever we have or noted system.import. So that's what we use in Webpack 2 for code splitting. Now, whenever it crosses over system.import, it's smart enough to understand that, all right, this bit of code that's predefined by system.import or wrapped around it, let's split that into a separate chunk. So we have our main bundle file, which is our, the granddaddy, everything, that's the big baller. And then you have the side hustlers, the little chunks that help you out whenever you want. So those are the separate routes. Cool? So, who over here knows Treeshaking? Cool. We have a few people, but not many. So I'll go ahead and explain what Treeshaking is and what exactly this slide is talking about. Now, there are many instances and many times where we can go ahead and maybe export or declare a particular file or particular element in a module as an export, but we never actually end up importing it. I don't know why, but we do that, right? So what ends up happening is we basically end up adding things that are not even used. And we don't want that. When we particularly care so much about, load time, a few milliseconds makes a big difference, and we have Jeff Bezos going ahead and saying, oh, 50 mils made us lose $15 million, and then we have a non-technical founder saying, oh, I need you to go ahead and get rid of this because, this is going to cost, so you don't want that. You really don't want that. So Treeshaking helps us fix that issue. So now, what tree shaking actually is, and I really like this, I guess, comparison I read somewhere, where tree shaking literally means think of Webpack as a live tree. It goes ahead and creates a dependency graph or literally a live tree. And any component that is exported which is not imported or used anywhere, think of it as a dead branch. So maybe you have Einstein who's really high on Red Bull or something, and instead of having an apple fall on him, he goes and shakes the tree, right? All the dead branches fall down, and that's how he figures out gravity. And those dead branches are basically those exports that are never imported. And tree shaking is basically left with all the live branches or dependency graphs that are basically used in our code. That's tree shaking in a non-technical way. Now, we also go ahead and say that Webpack 2 imports natively. That means it does not convert our code to CommonJS. With CommonJS, everything that is exported, like I said, is included in the final build, which is not what we want, right? Now, a very basic Webpack config file. So Webpack has 4 elements, 4 primary elements. And please correct me if I'm wrong. We have an entry, we have an output, we also have our loaders, and we have our plugins. Agreed? Yep? Cool. Now, an entry is basically where we're telling our entire application this is where it begins. This is the parent, this is the start. And then the output is where we say, all right, this is where I'm going to dump everything after everything's compiled. It looks like something from Matrix, but kind of dodgy because it's not as cool. We have our modules, which are loaders. Our loaders basically helps Webpack understand what we're loading. Now, we need to understand that the concept of Webpack is to control all assets for the code. That means we don't want our browser to control all these bits of information. We want Webpack to handle it for us. And now Webpack is made to handle JavaScript. It's not made to handle CSS files, HTML files, JPEG files, or memes, or GIFs, right? Or GIFs. Didn't want to hurt anyone, sorry. So what we end up using is something called loaders. Loaders basically help make sense of these files and allow Webpack to add these to our dependency graph as modules, right? And then we have presets. Or plugins, they basically help parse this bit of information that we've added on. Now, what ends up happening is we end up using something called, with Webpack 2, it comes out of the box where we can go ahead and add tree shaking. Sorry, I think I just might have lost train of thought, so I don't want to. Yeah, cool. And we use our Babel loader, and we use something called the ES 2015 preset or plugin. Now, also this is Webpack 2. For some of us who use Webpack, you might have seen that really ugly query string that looks like, minimized code put in together. I don't know which smart man or woman decided to add that, but they did. But now we have it very segregated, where we have options, we have presets, we have queries, so it looks very broken down and very nice and pretty. So one thing I wanted to mention over here is modules fault. So most of us will go ahead and say, all right, Webpack 2, cool, tree shake, I'll go ahead and do that, and then find V on LinkedIn and blame him when it's not working. So you need to make sure you put modules false there, because what happens is, by default, Babel or ES 2015 adds in another plugin, I don't remember the exact name, which goes ahead and converts our code, our modules, to CommonJS. That's not what we want. We want to kind of avoid CommonJS, because when Webpack is parsing through our code, it can only parse through static-driven structures. Now, what do I mean by static-driven structures? Now, who over here uses ES6 for their modules? Ballers, nice, everyone, cool. So ES6 lets us go ahead and import and export, and go ahead and do named imports, named exports, destructuring, and all that cool stuff, right? But when we're using CommonJS, we use stuff like require, and we have to require maybe at the top. But a cool thing about modules or ES6 modules is we need to import everything at the top or the root. We can't dynamically go ahead and import something on the fly. We can't say, if something, go ahead and import it. Not going to work, right? But with CommonJS, we can literally go ahead and say, if something is true, require a file. Now, when we do that, when we say require a file like that dynamically, Webpack can't pick it up. So therefore, we need to make sure that we don't have CommonJS modules, and we have everything left in ES6, which is static. That means Webpack can pick these things up and go ahead and say, all right, I know what this code is. I know this is being imported and this is being exported wherever it is, and I don't want it to happen. Cool? So that's a bit of tree shaking. That's Webpack. That's a little bit of optimization you guys can kick into your code. Webpack 2 is really great if you haven't moved into it. You should, because people are getting like Apple. They force you to move to new things by breaking everything else. So try to do that. So kind of the main topic, React Router. Who over here uses React Router as to some other routing module? React Router. Cool. And any other React routing tool? Who? There we go. We have one. We have one. Cool. I'm assuming you set state and your own. Yeah, there we go. Fair enough. Fair enough. Cool. So statistically, this is random facts that you don't care about, but you can always throw around. If I read wrong, 77% of all React applications across the world use React Router, right? And this is basically a configuration for lazy loading a route. This is it. It's really easy. It's very straightforward. It looks daunting at first, but it's not. So what exactly is happening here? We are going ahead and importing an application or importing a particular component. And then what we do, remember the system.import thing that I showed you guys? So that's what we type up over here. We say system.import, then we import a particular element, and then obviously that returns a promise. And what this load route basically does is it helps call back on that promise and load that component. This is for one particular route. We can have 15 other routes. Very straightforward. Once you have 15 routes, you can just pretty much lump them up into one array and load them into your main parent application. So you see where we have root route. That root route can literally be an array of all these individual routes. Few questions might pop up. All right, so what happens, and this is where I go ahead and load this application and do a plus, plus, plus. All right, so this is an application that is lazy loaded. Cool? And it's actually loaded with React Router and Webpack 2. You might say, all right, cool. You go ahead and load an application, loads the home page. Then what? I want to go ahead and load the about page, which is lazy loaded. Fine. But does that mean every single time I click on that route, it goes ahead and reloads it? No. Webpack's smart enough to pick that up for you. So let's go through a small networking or network check. So if I click on about, and that was a fail. So you see it picked up bundle to 2.bundle.js, which is tiny. Look at that. That's 835 bytes, right? So that's a small chunk of our code that's loaded on. Now I'll go back to my home page, and I'll go back again. Was it about that I clicked on? All right, I'll click on about. So if I click on about, you see that no network request is made the second time round. It basically caches that route, so it makes it feel like it's a single page application. So that's the advantage you get from this. That's how cool it is. That's how easy it is by just doing a simple step such as that. Now let's go back to this. I'll go a little quick. All right, now what's happening? System.import are treated as imports to separate chunks. Now, if we, like I said, access on a random route, it goes ahead and loads that calls get component, which is asynchronous. And once it calls that asynchronous route, system.import is a polyfill, so it executes a JSONP request. Anyone know what a JSONP request is? OK, cool. Anyone mind telling me what a JSONP request is? Cool, go for it.
OK, hi. So JSONP request is a request that will return prepended, I think it's called, JavaScript function. And the idea is that when you execute JSONP request, you provide a name of a callback function that will be wrapping the returned code. This code is usually inserted into a page as a script, as a part of script tag, and it executes your function, passing the data that is returned. Usually that's the way to circumvent cross-site. Well, before course was widely adopted, that was the way to have cross-site scripting.
Cool. Thank you. I learned a few things from that. This is good. I was just going to say it's a protected request, but yeah, that works. I knew that. I did. No, I didn't. So, like I said, the last 2 points prove to what we just saw in the demo. It goes ahead and requests that bit of information and then caches it. And that was the app that I was going to show you guys. Now Reactrata 4, this is really cool. When Reactrata 4 came out, or when React 16 came out, a lot of us might have seen React 16 come out because whenever you do npm install, there's just yellow and red everywhere nowadays. And there's one annoying system import plugin that keeps bugging me. ESLint import plugin. So yeah, React likes breaking stuff, and my team has a lot of fun doing that. So why Reactrata 4? What's the big deal? What's happening? How does it make our life easier? And why am I talking about it? And I'll go on quick. Reactrata till now has been static routes. Agreed? That means we go ahead to a particular route, it loads a static route. It's literally a static route. And then we have to emulate a component, which is a page, and that goes ahead and loads something, right? So it's not exactly React. It's something that's a router, and then we use React on top of it. Now, the guys who made the Reactrata, the React training guys, went ahead and said, look, there's a few issues we have with this. Hot module reloading is a pain. If I had to go ahead and do HMR or hot module reloading, I would literally have to take the entire new route config from what I just changed, preserve the old config, parse it, find the relevant code on the browser, paste it in, and then check whether this is even the right route that I'm on, and then reload it, right? And Reactrata went ahead and did a lot of things that React already did on enter, on leave, on change, all things that React had built in itself, right? So we're repeating code in production, which we really don't care about, or we shouldn't be doing. So Reactrata was just a bunch of static routes. So they rewrote a bit, a lot. So they changed the entire API, and the focus of this is it makes life so much easier when we're trying to dynamically load stuff in. It's very different now. Reactrata is literally just components. That's all Reactrata is. We no longer have static routes. We just have components loaded based on a particular match. It's just for the simplicity of it, a giant switch statement that sees, hey, this is this, let's go ahead and load this component. This is this, let's go ahead and load this component. When you're a route, you're pretty much just running a component. So you can download or load your app really quick, really coolly, and very easily. Now, how do we go ahead and do this? So Reactrata 4 uses Webpack loaders, which is basically, Webpack's bundle loader. Webpack's bundle loader has been used for a while now. It's quite straightforward. So we go ahead and require, so you know how I have file.js, assume that to be your about file, whatever file it is, right? And that loads in basically a function, which is stored in load. And that load variable then gets, sorry if I use var and I triggered anyone, it's const. just saying. So the load goes ahead, and when it's invoked to the callback, and that callback is basically the module, which is file.js. Cool? That's as simple as it is. And we'll see the paradigm of this being applied when we go ahead and create our Reactrata 4. This is stolen straight from Reactrata 4, so I call no dibs on it. The screenshot I did, but the rest of them was them. You load something, which is a something file, and we have this bundle file this bundle component that they created, and that's it. By just simply doing this, you're dynamically loading your component that is wrapped inside this particular module. That's as simple as it is. I really think you guys should go ahead and implement it. I'll show you what exactly is happening because it's quite straightforward. So just remember this, that we have a load prop that goes ahead and loads our particular function, our variable called load something. And previous slide, load something receives a callback. Cool? Yes? Okay. And yeah, again, this is quite straightforward. We can go ahead and pass in a simple loading component until our main component loads in. And it's just done. It's really simple. So if you have a main app that has 15 components, some of them are heavier than the other, load the main one, and the rest of them come on when they have to. It's ridiculously easy. And I mean, come on, I didn't expect you guys to be able to see that. But there you go. I guess we'll have to work off of this. Now, without actually walking guys through React code, just a bit of it that I'll walk you through is we go ahead and receive the props.load, which is what we saw in the last slide. Props.load goes ahead and, remember, is that variable that has a function that receives a callback. So we go ahead and pass a callback function over here, which goes ahead and sets the state to that particular component. And when it does, we go ahead and just call, because our child is basically a function, if you remember from our previous slide, the new state value, which is basically our component itself. Cool? Yes? Did I walk through it to now? Okay, cool. All right. Like I said, it's been there for a long time, helps us use lazy loading. And there's a reason why we use bundle loader as to import. So import's actually been suggested, but it hasn't been implemented yet. But bundle loader does one thing. Okay? The first or the most cool thing that I saw is that the second time around something is called, it doesn't have that flashing screen that shows up sometimes if you guys have seen it. Where if you load something else or you have a route reload, there's a little tiny flash and people get very crazy about it. Yeah, that's not there anymore because you can just go ahead and do that. And if you want to dynamically load a route, just wrap it in bundle. That's it. It's as simple as that. It's really cool. Yeah, and you can do really cool things. The easiest thing is preloading. Preloading was just such a scary thing before. Oh, how do I preload? Marketers are like, oh, product managers are like, look, I think people who visited homepage, they go to product page, and then they go to this. And you sit there trying to map out how we can preload these things. It's really, really straightforward with Reactrata for preloading. It's literally that. So we have two components, about, dashboard. We have our main app. By simply doing this, we go ahead and preload our about page. That's it. On component, did mount, preload about page, and now if anyone goes ahead and visits about page, that's preloaded because we know that our customers go ahead and visit the about page more than they visit the dashboard page. And that's that. That's all we need to worry about. So that's route splitting. Really easy, right? Yes? Yes? Cool. I mean, I'm not giving you a choice to talk, but I'll walk through this really quickly as well. Okay, who knows what long-term vendor caching is over here? Cool. The man who made Reactrata, can you tell me what vendor caching is? I can give you a mic or you can shout.
No, I can speak.
Cool.
Yes. So you have a proper hash for your file.
Yep.
You add it to your bundle, like you just dynamically calculate it from all the files in your bundle, and you can set the expiry time to be infinite. So this file will have actually a name with unique hash, and it will be cached forever. And it doesn't matter, you don't really care, because if any of those files in the bundle will change, the hash will be different, so your browser will recache again.
I shouldn't have asked because that's my, yeah, anyway. Yes, you are right. That's basically what I'm going to talk about for the next few seconds. But so whenever we use Webpack to create our code, we go ahead and create a hash, a unique hash, right? That sometimes contains our main code as well as our vendor code. What is vendor code? As I was learning programming and we got into JavaScript from C++ and Arduinos, there's all these fancy words people used to feel important. Vendor code is nothing but code, but that is your NPM modules, right? Or whichever modules you have. That's not repeatedly changed unless someone decides to go ahead and click the delete button from NPM. It's not fun. So we have two issues. We can load our code, which is basically our unique hash, like you mentioned, which goes ahead and caches in our browser, right? Our browser is smart enough to go ahead and see, hey, am I reloading something that already exists? If I am, let me use what's inside within my cache, or I'll load something new. This gives us a kind of an issue. So every single time we redeploy something, we end up changing our bundle code, which means all our users across the world will end up using or re-downloading code that we necessarily didn't change, right? What we can do is quite straightforward. With Webpack, have a vendor and a main, and use a system such as this, which goes ahead and creates two separate files, like I said, but we end up causing that thing where every single time we rebuild, we end up creating a unique hash, and the client will have to download it each and every single time because nothing's preserved. Like I said, we don't like change. We want to make sure that when code doesn't change, we don't want the file name to change because, low frequency changes aren't exactly something we need to worry about. We can use Webpack's Common Chunks plugin. Who knows Webpack's Common Chunk plugin over here? Yes, cool. This time I will tell you what it is. Webpack's Common Chunk plugin is basically, in the broader spectrum, if we have separate chunks, some of them basically require the same plugin or the same module or something, it goes ahead and instead of requiring them for each and every single chunk, creates one file that has all of them and it's distributed to all these different chunks. Cool. Now, simple config, very simple config. By simply doing this, by having chunk hash written over there, what we end up saying is, all right, now if our vendor code doesn't change, don't change the file name of our vendor code. Only the main.js, go ahead and change that. So every time a new user goes ahead and downloads, or an old user downloads new code, they're only downloading the changes, but not the vendor code. So that's literally a few hundred kilobytes that are missed from the redownload. Cool? Chunk hash, don't use it in dev because it would create a unique chunk each and every single time. That's not fun. Gluing it up really quickly. Now we go ahead and put this file in our HTML code. Now we can't do the same in production because we have different file names. We use something called Webpack Manifest plugin. That's just another plugin. All the Webpack Manifest plugin goes ahead and does is it creates a basic mapping for us. It lets us get access to Webpack's output, such as this. Again, the screenshot was my credits, but the code is not mine. And we pretty much can go ahead and get its JSON output and then paste it into our HTML because our front end would want access to this. Webpack basically uses identifiers during compilation. Now, like I said, identifiers are used as to file names because they're cheap. Cheaper. They're cheaper to download. Yeah, sure. And they're basically mapped into this chunk file or chunk manifest file, and they map all our code according to each requirement of download. Again, we have an issue with this. Each and every single time we change our code, we again end up having downloading different pieces of information because our Webpack is basically, it sees something different, but it is not smart enough to realize that something's changed that's not meant to change. So what we end up doing is we remove our manifest from our entry and we basically manually chuck it in. Something like this. Very straightforward. We get our manifest from the Webpack chunk plugin that I showed, and that gives us an output. We can go ahead and just paste. This is, again, you'd ideally like to automate all of this. You don't want to manually copy paste the output, but this is just for, if you do apples and banana, get in touch with me. That's a pretty cool output thing that you have. But yeah, a basic demo, if you guys can see. So we have, if you look at our vendor stays the same, EF2 and EF2. However, we have a small change that you end up noticing in the second one, which is our chunk file. The 1 point something, that's 5AA8. This is 9 2B1. Our main stays the same. Our main stays the same. However, we only have a change in whatever else changed. This is a small change that I made over here, but you end up seeing that everything's cached, everything's maintained, the file names stay the same, so none of our production code is affected. Very simple config, and it's really straightforward to set up. And I think this is the last part of it. Yes, it is. That's all. Thank you.